What's a little more involved are what we call homogeneous mixtures. Again, also called solutions, where the mixture of the different substances are evenly distributed everywhere, so that it's very hard to identify one area of the mixture versus another. Some common examples. So I'm going to take some water, and I'm going to take just a pinch of salt. You can tell I'm staying on kitchen chemistry right now because, I mean, you can even try this at home, the safe stuff, the kitchen chemistry. I'm going to put a little salt. In with the water. Now, I don't know if we can tell on the camera, but you can see maybe little grains of salt down there, maybe not. They've already kind of dissolved. Let's get a little more salt, shall we? A little more salt in here. There, we saw it go to the bottom there. We can see it raining down there. Now, if I take this, give a little mix it all up. All the salt is dissolved in the water, meaning I don't know where the salt is, where the water is, but I will tell you that all the salt has dispersed evenly throughout all the water. So no matter what little sample of water I take out of here, it's going to have the same percentage of salt to water. That salt is distributed perfectly, or nearly perfectly, throughout all the water. Since it's nearly the same everywhere, it's, again, called a homogeneous mixture, and again, also known as a solution. I mean, I can do the same thing with, and we've already seen this, I have my copper sulfate, my blue crystal. It's pretty. And again, I can take some water. And this is going to take a minute. But I could take that, stir it up. And my solution's going to start to go light blue. And I'm going to come back to this. It takes a little minute for it to dissolve, but eventually will all dissolve. And I'll show you another homogeneous mixture. Now, when we deal with homogeneous mixtures, we generally have two major parts within a homogeneous mixture. We have a solute and a solvent. Now, we didn't really have that with a heterogeneous mixture. It really is not applicable. But in a homogeneous mixture, solute and solvent. Solute is the material that you are dissolving. Usually it's the material you have less of. And so in these two cases with the copper sulfate and the sodium chloride in water, the salt and the copper sulfate, they were both the solutes. And in both of these cases, the solvent is what's doing the dissolving. The solvent is water in both of these cases. Starting to dissolve, light blue. Little crystals on the bottom. I'll get those to dissolve. It'll take another couple minutes. Now, when water is our solvent, in both of these previous cases they were, that's called an aqueous solution. Aqueous, aquarium, right? Water solution. So aqueous solution is a special kind of homogeneous mixture when water is the solvent. Now, there we go. Light blue, crystals are gone, homogeneous. Water does not have to be the only solvent. Okay. You can use other organic materials such as acetone or some alcohols to dissolve things. And we're going to get into second half of the year what dissolves and what and why. But homogeneous mixtures do not always have to be liquid based. They don't have to be liquid based. As a matter of fact, air is considered a homogeneous mixture. It's considered a solution. Think about it. I don't know if you know the composition of air. Any ideas? What the major ingredient of air is? Well, we know we need oxygen. That's got to be in the air. That makes a good percentage of not nearly 20%, but close. We have a lot of nitrogen in the air. A lot of nitrogen. It makes up the bulk of the air. And then we have, of course, what we breathe out, carbon dioxide, which the trees and grass and plants love. And then we have all kinds of other things in the air, some minor pollutants, dust, pollen, other gases from processes. You have what they call the NOxes, which are nitrogen-based small gas compounds that are floating around. Really, some of them are not that great. We have sulfur-based compounds floating around in the air from industry and pollution. Those are on them a small percentage of the air, but they're still here. So air is a big solution where nitrogen, since it's the bulk of the air around us, that's the solvent. And we know that it's mixed equally. We know air is mixed equally just about everywhere, at least in our local environment, because we know the amount of oxygen is roughly the same wherever I go, in this building or in your home or walking down the street. I mean, can you imagine a world where if it were heterogeneous? If air were heterogeneous and you have to find the pockets of oxygen to breathe? That wouldn't be very nice. It would make existence kind of nearly impossible. Sorry, lost it for a minute. Air is considered a solution. It is a homogeneous mixture. The last kind of homogeneous mixture is an alloy, which is a mixture of metals. And this now, although mostly made of iron, it has some other things in it to make what we call steel. And there are different versions of steel. Sometimes they throw a little carbon, sometimes they throw in other elements, depending on what the process is and how they want to strengthen the iron. Well, how do I get metals to mix in an alloy? Well, what do you think? Yeah, you gotta melt them. So even though an alloy, typically solid, in order to get it mixed, in order to get those metals mixed, we do have to go back to the liquid state. Melt down those metals, mix them together, let them become a homogeneous solution. Then we pour it into molds and let it harden back to a solid so we can use it. Sometimes it's going to be difficult to tell the difference between a heterogeneous and homogeneous mixture. Sometimes the difference between this gets gray. For instance, I have here some soda. And when I pour it, lots of bubbles. And people are like, well, it's an aqueous solution because, it's just water and sugar and color maybe, if it's depending on soda. But see all those bubbles? Those bubbles right now make this a heterogeneous solution. Or a heterogeneous mixture, I'm sorry, not a solution. I have pockets of sugar and water, but then I have the pockets of the carbon dioxide gas. And they're very visible. And so therefore heterogeneous. Now if I were to take this and really, whoa, spilling it. Really shake it around. And basically get rid of all the excess carbon dioxide. And really knock down those bubbles. And I didn't even quite do it enough, but you can continue mixing it and really knock down those bubbles. If you get rid of those bubbles, you flatten the soda, if you will, suddenly you go from a heterogeneous mixture to a homogeneous mixture. And we will practice this in the next coming days. Thank you for your attention.